All right, it's time for our fifth Christmas video. Today I just want to take a look at a very specific type of problem that I'm pretty confident you guys are going to face on the AP exam. It reads like this. It says, if f of x is continuous and differentiable on the interval negative infinity to positive infinity, then solve for a. So they give us f of x. The tricky thing here is that it's a piecewise function and the leading coefficients are given to us in terms of variables. So this is kind of a tricky question. It's something we can definitely solve, though. We just have to have an understanding of what's going on here. First of all, it has to be continuous. If this piecewise function is going to be continuous, we have to understand where the piecewise function is basically separating into its two separate pieces. Well, in this case, it's pretty obvious that it's breaking off at positive 1. So this is the part of the function when x is less than or equal to 1, and then it's this guy, bx squared minus 3x, when x is greater than 1. So everything we're going to be doing for this problem revolves around the fact that the function could be changing at x equals 1. So if it's continuous, it has to have the same y value. So if it has the same y value, we can just basically take the first part of the piecewise function and the second part and set them equal when x equals 1. So that's the first thing we're going to do. I'm going to take the two parts of the piecewise function, ax to the fourth plus 5x, and we're going to set that equal to bx squared minus 3x. However, we do know that x is 1 for the part of the graph we're concerned about. So if I plug in 1, well, 1's a super easy value to plug in. We love 1, don't we? 1 to the fourth is 1 times a is a. 1 times 5 is 5. So we get a plus 5 equals 1 squared is still 1 times b is b, and then minus 3x. Plug in 1 times negative 3, we get negative 3. We can simplify a little bit. Let's put the variables on one side and the constant on the other. If I do that, I'm going to have to subtract b, and then I'm going to subtract 5. If I do that, I should get a minus b equals negative 8. So that in and of itself is not very helpful because I have a minus b equals negative 8. There's two variables. There's only one equation. That's not something I can solve. So what we can do, though, is get another equation. The way we're going to get another equation is by using the second part of the question. It says f of x is continuous and differentiable. If it's differentiable, it's not simply enough that it's continuous. If it's differentiable, it has to be continuous, but if it's differentiable, it also means that the slope of the tangent line at that point has to be exactly the same. So what I can do here is I can take the derivative of both parts of the piecewise function and then plug in 1, because we are again concerned with when x equals 1, and then set those guys equal. That's going to give us another equation involving a and b. And once I have two variables and two equations, that's a system of equations that I can solve using the skills that we've learned in Algebra 1, Algebra 2, math analysis even. So let's do that. Let's take the derivative of both of them, plug in 1 for x, and then see what the resulting equation is, and then we can use that to solve our system. So ax to the fourth, if I take the derivative of that, the 4 is going to come out front, and I get 4a x to the third. Plus 5x, the derivative of 5x, very simply 5. And we're going to set that equal to the bottom part of the piecewise function. If I do that, I get 2 comes out front times b, and then x squared decreases a degree, becoming just x. And then minus 3x, that's just simply minus 3. Again, the x value is 1, so whenever I see x, I can substitute in 1. If I do that here, 1 to the third is 1 times 4 is 4, so we get 4a plus 5. 2bx, well, 1 is x, or x is 1, so plug it in, we get 2b minus 3. I can solve that, put it in standard form basically, and if I do that, we're going to get 4a minus 2b, and then subtract the 5 again, we get negative 8. Now, do you notice here we have one equation? Here we have two equations. There's two equations with two variables each. They do have the same variables, so I can solve it. We could do substitution. That wouldn't be that bad because I could basically just move the negative b over and make it a equals b minus 8. If we did that, we could take that, plug it in here, solve. But my personal preference for solving systems equations is definitely linear elimination. So if we do that, basically I like to put one on top of the other. So let's put the 4a minus 2b right here, and that's going to equal -8. So there's our second equation. In this case, neither of the variables cancel right away. A and 4a won't cancel if I add them up. Negative b and negative 2b won't cancel if I add them up. However, I can multiply one of the equations by a number that allows me to eliminate. In this case, keep in mind we want to solve for a. If I want to solve for a, then it makes sense then that I want the b's to cancel out. So I can multiply the top equation by, in this case, -2, and if I do that, then the b's will cancel out. So this equation, if I just alter the first equation, I'm going to get -2a, because -2 times a is -2a, -2 times -b is now +2b, and then -2 times -8, pretty sure that's 16. So now I have this equation and this equation. Do you notice if I was to add them, the b's would cancel? That's exactly what I want to happen. So now I have 4a minus 2a is 2a. -8 plus 16, pretty sure that's 8. So I have 2a equals 8. Pretty sure then that a equals 4. All right. So we were able to solve this question. I showed you all the steps you're needing to do. One other thing I would like to add, though, is if a function is continuous, it's not enough for it to be differentiable. Just because if I have an absolute value function like that, is it continuous? It most certainly is. But it's not differentiable. The reason why, here, this line is going to have a completely different slope than that line right there as it approaches whatever this x value is. All right. So that's why we had to set them both equal the original functions to find the y value, and we took the derivative, set those guys equal, and then this shows that it's actually differentiable. So this part right here is showing that it is differentiable. This part right here is showing that it is continuous. All right, and once we solved it, we did get a equals 4. You guys are going to take a stab at another question right now. So on a separate sheet of paper, you're going to try this problem out and turn it in when we get back from break. The first person, again, that puts the answer on YouTube gets a shout out and also a homework credit when we get back. So this question right here states, if f of x is continuous and differentiable on the interval -∞ to infinity, then solve for b. So f of x equals ax to the third plus 6x when x is less than or equal to 2, and also the other part of the piecewise function, bx squared minus 4x when x is greater than 2. All right, so I hope you're able to have a lot of success with this problem, and I hope someone is able to come up with the answer very, very quickly. All right, hope you're having a great Christmas break, and I'll talk to you guys later.